Welcome, everybody. We're going to go over the homework that is due on September 25th, 2020. It starts with a congruent statement comparing the correspondings in each set of congruent figures. Okay, we have corresponding parts are marked on sides with a dash, two dashes, then three dashes matches with three dashes. And then angles are marked with arcs. So we have a single arc, a double arc, unless there's a 90-degree angle, and you mark that with a square. So let's start. We have a congruency statement. We have AB. A segment has a line on top, has a line segment on top of it. Now we have to keep the direction has to also stay in order. So FG, and then for this angle, if we do BAC, it's congruent to, so we went single to 90 to 2. We need to go find the matching angle, which is here, single 92, angle GFJ. You have to use three letters, okay, with the middle letter being the angle that's formed. Don't name this angle A and A, angle, oh wait, I messed up. Oh no, that's right. Don't call this angle A and call that angle F. You need to use three letters. Okay. All right. So you do the same thing for. You would do that three times. I'm not going to do all.
Mr. Gary, we can't see your screen.
You're not sharing it.
Oh.
We can only see you.
All right. How about now? You can see it now, right?
Yeah.
Okay. Well, then I marked each one with each side with a dash, a unique dash matching, and each angle with an arc that matches. So that's all you missed. So I'll do the next one. So if I do AC here, from the 90 to 2, I need to go to the 90 degree to the 2. So it would be FG. J, sorry. FJ. So they both share the two marks, and then the direction is correct. So here I haven't done, let's do this double arced one, ACB. Is congruent ACB. So you go to the 90, FJG. Okay, and then you have to do one more. For purposes of time, you do the last one. Okay, reason abstractly. We had this problem in our on our notes. So we started with marking the vertical angle can be congruent. Angle A is obtuse. That one's obtuse. This one's acute. Mark it with 3. Draw arc and tick marks. So the shortest side, I usually go opposite my marks. Double mark, then we have one left, triple mark. And then we find X. We know they're equal because the marks make them equal. 4x minus 2 equals 22. Add 2 to both sides. And you get 4x equals 24. So x equals 6. All right, and then we have another one, a figure at the right. Now on your on our notes, I gave you this last length. It's 5, 12, 13. So then you could set the 13 equal to x plus 3. And you subtract 3, and you get 10 equals x. And then it tells you to describe the transformation. Well, it looks like it would be I could rotate this 180 degrees. Sorry. If this is the center about P, rotate triangle FEG 180 degrees about point P. So that takes care of most of the first page. Okay. The first assignment page. Again, this will be a video uploaded so you can get the rest of it then. All right, there's an error here. It says triangle ABC, so A, B, C, single tick, double tick, triple tick, or arc, is congruent to triangle D, E, F. Okay? Mandar is making a congruent statement for the congruent triangle shown. Find his mistake and correct it. So let's look at it again. A, B, C, D, E, F. Look at the order again. A is a single mark, B is a double mark, C is a triple mark. Then he says it's congruent to D, which is a single, then a triple and a double. So he has the order is incorrect. His order is incorrect. You want to fix it, right? So if he keeps it as ABC, triangle ABC, makes a congruency statement, I need to go single, double, triple. So I go single, double, triple. D, F, E. Yeah, to address your chat, this will be put up in a video so you can rewatch it. All right, it's hard to read here. Persevere with problems. Each pre-image and image are similar. This is a very important question. These are the types that are going to be on your CSA next week. Describe a sequence of transformation that maps the pre-image onto the image. Okay, so first you got to find the prime marks, which tell you that this is the image. And this is the pre-image. And we have to transformation that maps the pre-image, this one, onto the image. Okay, so first off, this one I'm gonna need to make it bigger, right? Look at the points here. It's 1, 1, 4, 1, 4, 3, and M is 1, 3. And then I look at the other one, I get 2, negative 2. Okay, well, those are twice as big as this one. I know that this point's probably it's J and J prime. They're double the size. So I already know that it's a dilate K equals 2. You got to dilate by 2. Because this one's going to be, I'm going to guess it's 8, negative 2 for K prime. I could just start doubling the numbers and making the y coordinate negative. So that's 2, negative 6, and 8, negative 6. Okay. So I already know that I'm going to dilate this rectangle by 2. Okay, so I dilate JKLM by 2. K equals 2. And then it's going to be over here. We already know the rule for reflecting over the x-axis is the y's change signs. So I'm going to reflect over reflect over the x-axis. Okay, So now again, identify which one's the image and the pre-image. Okay. So triangle ABC is the pre-image. Sorry. Which makes A prime, B prime, C prime the image. All right. Now look where this first coordinate is in the image. It's at 0, 0. So now this time let's move the pre-image first. Let's translate it. Translate triangle ABC. How far do we need to translate it? We need to get it one to the right and one down. So if you want to write it in words, translate one right, one down. Or if you want to write the rule, x plus 1, y minus 1, that's fine too. Once you translate it one right, one down, now it's on there. Now we just got to figure out how far to blow it up. Okay? If I had moved this, let me imagine that B prime would be at, if I go one right, if I take this point one right, one down, that would be, this is thinking, it would be at 1, 1. And this point's at 4, 4. So I need to dilate it and make it 4 times bigger. So it's important to really think about the whole scenario before you start doing it, going too fast. Now I really like this graphic organizer here. Use this graphic organizer to compare and contrast. So we're doing some real high order thinking here. Similar and congruent, you're finding out the differences. Let's start with angle measures in figures that are exactly the same. Between two, we're talking about between two congruent figures. So when two figures are congruent, that means they have the same shape and the same size under this column, right? So we have congruent sides. So far it's pretty easy. That's a U. And we have congruent angles. And we discussed in this class quite a bit the fact that we discussed this in our notes, that then you could come across a figure that is similar. Okay, so these are similar figures. Sorry, similar triangles. A, B, C, and D, E, F. We looked at this and we said, okay, well, the angle measures are the same, and that determines the shape of the object. But the size of the object is determined by the side lengths. And to be similar, then we need to find the scale factor. So if you go from the small triangle to the large triangle, small to large, we get a scale factor of 5 to 15, or 1 over 3. Or I should say, you're blowing up, so this would be k equals 3. If you're shrinking it, then k equals 1/3. This, I should just say, to reduce, and this is if you're enlarging. So what do we know? We know that they are proportional. Again, this will be in the video. You already have it in your notes. So angles were the same or congruent. Side measures are proportional. You could put, if you want to, the ratios are the same. Now, congruent figures only use the rigid transformations. You could list them, the rigid transformations, if you want. Translate, reflect, and rotate. This one uses all four. Oh yeah, I'm sorry. I had clipped and put the page numbers in here in various spots, but thank you. What is this page? 542? Okay, and then we do a little modeling with mathematics. Here's an image. This is an image of triangle DEF after two transformations. So this guy right here is an image, and you're going back in thought, backwards, trying to go back. How do I get to the pre-image? Well, they actually give it to you. It said it went two transformations. Vertices D prime 3, 3, E prime 6, 3, and F prime 3, negative 6. So I'm going to graph those. 3, 3, D prime, 6, 3, E prime, and 3, negative 6. 1, 2, ooh, 1, 2, 3, 3, 6, 3, and 3, negative 6. 3. That's really big. Okay, let's start thinking about first the scale factor. Okay, let's look at the side lengths. It's length 1, length 3, 1, 2, 3, 1, 2, 3, and this one's probably 1, 2, 3, 4. That's 9. Okay, let's not worry about the diagonal since we haven't done the Pythagorean theorem yet. But we do see that this thing has to be enlarged. So you do have to make it times 3, but let's put it in the right position first. Okay, how do we do that? If I rotate this 90 degrees about the origin, if I turn it one turn, this point right here is going to come to that point. I hope this is going to be the right transformation. And where is this located? 3, 3. So we need to get this triangle into the position of, we've got to get it to 1, 1. And we need E prime to be at 6, 3. So if we rotate this 1 time, yes, D will move to 1, 1. E prime should move to 2, 1 after the rotation. And then F prime will move down here. That's why you have this negative down here. 3, negative 6. So F prime would move to 1, negative 2. And then if you multiply by 3. So it is a rotate triangle DEF 90 degrees. Now we need a direction. Is this with the clock or against the clock? And we need to know what we're rotating about. And then we can dilate by K equals 3. So a very complicated, really good question. Really requires a lot of higher order thinking skills. Okay, let's go to the next. Next
Can
up,
you go back for a second to the other page?
sure. I'm sorry, but
Thank you. Sorry.
it's because I'm recording, and if I have to pause for a while, I was gonna post this on YouTube. So if I pause for a long time, the video gets longer. It's harder to upload. So it's really hard for me to just.
Okay, sorry. Go ahead.
All right, then the last of the homework was here, page 548. We did 3 and 4 already, so you should have that in your notes. We looked at this, and we talked about what transformation. We had to put a point out here. I think I did a fairly poor job though of saying that. See the triple mark? If I rotate this, it rotates actually. If you did the rotation, it actually ends up over here because then you shrink it. So if you rotate about point P, FGH, you just 180 degrees about point P. That gets you to over here, the whole triangle, and then you can dilate. And you have to look at the scale factor. If we're treating this as the pre-image and we're mapping it to the image, then we go 6 to 3. We reduce by dilate. K equals 1/2. Oh, I'm sorry. Let me push that over there. And then finding the missing sides is a little bit harder. Oh, let's cut that off. I think that's a 3. Yeah, it's a 3. So we'll do this. Let's practice with these to see if they are. We don't have enough angle information here to determine if they're similar. So we have to look at the side ratios. We do 3 over 5 equals 4 over 12. We know that's already false. And 5 over 13. These are not equivalent fractions, so not similar. That's the similar symbol. Here, this is rotated. You know you got to rotate it around 180 degrees. The angles are all given as similar. So, I mean, the angles are all congruent, so these figures are going to have to be, let's see. Okay, so the 6 goes with this 8, or 8 to 6. Let's do 8 to 6, 8 to 6. The diagonal is 10 over 7.5, and then 18 over 13.5. These I could do pretty fast. This is 4/3. This is 4/3. This one's 4/3. That math I can't do so fast in my head. But it looks like 4.5, 4.5, 4.5, 4.5 will get me there. So yes, it's 4 to 3. So check. This is yes. Similar. And I apologize. I know I'm going a little bit fast, but I wanted to get through the whole thing. We're almost done, actually. This is problem 3. And we already determined the rotation and dilation to get you over here. The missing side measures are a little trickier. Let's match them up. It's 6 over 3 This x goes with that. So we're going large to small. X over 6. You might remember this from our notes too. 9 over y. So we could see the relationship. This is given that they're similar already. So we already know that they're similar. So then we start looking at the scale factor. The numerator is twice the size as the denominator. So this numerator would have to be 12 to keep that as a true. To keep that true, x has to equal 12. And then we can find y. Now we're thinking the other way. So we know the top number is twice the size here, so 9 is twice the size of y. Y would have to be 4.5, or 9/2. I'll circle them so that it's not confusing. We didn't do this problem. I think we ran out of time. But this is another one where you have to rotate it around. A lot of rotations here. If I put a point P here, it's still a rotation. And you have to pick one of them to rotate. So you can rotate the small figure to the large figure. It determines on how I want to set up the ratios. Do I want to do large to small? I think I do. So I want to rotate the large triangle 180 degrees about point P. And then the side measures. Okay, if I'm doing that, then 5 goes with 4. 5 goes with 4. 10 goes with 8. And then x goes with 4.8. That's a little tricky. I could break, if I think of a force, there's 5 of them. So I could think of going by 1s. This one I could think of going by 2s. This one I have to go by 1.2s. So that would end up x equals 6.0. And I'm going to rate myself as ready to move on. With that, that is the homework, entire homework review. So I hope that you got a little bit out of that. Let's hope I recorded it correctly.